Today on My Climate Journey's Startup Series, our guest is Eric Law, CEO and co-founder of Urban Machine. Urban Machine develops robotics and AI to reclaim lumber from construction and demolition for reuse. They claim that 37 million tons of wood goes into landfills annually, and much of that wood could be reused. Their robotic machines specialize in the necessary steps to prep wood for reconditioning. Eric has spent his career in the construction and contracting space. He's worked in large construction, and he's worked to create and sell software for the industry. We start out our chat today with an overview of the construction space, who the players are, and what issues they're grappling with, including how they think about emissions and sustainability. Urban Machine raised a seed round in 2022, led by Lower Carbon Capital with participation from GV, or Google Ventures. I enjoyed hearing from Eric about the problems they're solving, their technology, and their vision for the future. But before we start, I'm Cody Sims.
I'm Yin Lu.
And I'm Jason Jacobs. And welcome to My Climate Journey.
This show is a growing body of knowledge focused on climate change and potential solutions.
In this podcast, we traverse disciplines, industries, and opinions to better understand and make sense of the formidable problem of climate change and all the ways people like you and I can help. Eric, welcome to the show.
Thank you, Cody. I'm glad to be on.
Okay, we are going deep in the world of construction, and I already love that in the background as we're talking, there's beeping forklifts and stuff happening, so we are on site in the thick of it, from what I can tell.
Yeah, this is our shop. I've got a wood wall behind me made out of reclaimed lumber, which is even more appropriate. And then our engineering shop today is moving lumber in and out of the shop for test materials. So you picked a good one for this podcast.
So, Eric, you've been in the construction space in various forms with construction companies, with software companies, et cetera, for seems like most of your career. Is that correct?
It is. I think I took about a 2-year hiatus and went pure tech.
So what is the construction industry grappling with today?
So the biggest challenge for the construction industry is really the trade and craft shortage. Just people are not going into construction. We've got a massive demand for infrastructure. You know, people want homes and apartments and bridges and all this good stuff. And we don't have the resources available to do it. And then when you tack on the climate challenges to go with it, it just makes it exponentially harder to build projects these days. So most of my career has been spent software and hardware side around finding solutions to that craft problem. I've partnered up with startups to bring robots on the job sites and help augment our craft. I had a SaaS company where we focused on moving data across project teams. And then today, here at Urban Machine, it's construction, it's robots, and it's sustainability as we essentially turn a waste material back into a raw material. I can go back into the buildings to help with that sustainability side of construction.
Well, we're going to dive all into Urban Machine in a minute. But first, you mentioned one of the issues that the construction industry is facing with is climate change and how they approach it. I definitely want to spend some time there establishing the broader context. What are the climate challenges that are front and center in construction?
So construction's got two challenges. You've got the embodied carbon in buildings, and then you've got the operational carbon that it actually takes to build the buildings, all the trucks and tractors and stuff like that. And it's massive. If you look at concrete, steel, the waste problem coming off the job sites. And one of the other bigger challenges that we have more specifically here in the United States is just, we have, I call it ADD with buildings. We get bored of them. We want a new design. We want a fresh building, and we tear down the old one, we throw it away, and we build a new one.
I live in Southern California. There is a lot of just building refresh for the sake of building refresh.
It's brutal, but it drives a massive part of the economy, all the designers and the contractors and everybody involved with it. Whereas you look at our counterparts over in Europe, buildings over there last for hundreds of years. So it's not a materials problem. It's purely just an attention problem with it. Everybody wants something shiny and new. So one of the big challenges for the design world today is how do we build a building that we can lightly update? How do we focus more on some paint and color changes versus wholesale taking the whole thing down? And then when we take these materials out of buildings, instead of sending them to a landfill or downcycling them, how do we use them again? How do we get that material to go back into that building so we can reduce costs? Because if you look at the supply chain for construction materials, copper travels out of Australia. Forest products travel out of Canada, Oregon, and Washington. Everything travels long, long distances, which is a massive amount of carbon in that shipping and the trains to get those materials to the urban centers where they're needed.
So when you talk about these different emissions problems, in particular, you said the embodied carbon being one, and then essentially the carbon from the operations being the other. I would think of these from a carbon accounting perspective as cement and steel, et cetera, are your scope 3. If you're a construction company, they're critically important, but you don't actually make them. So you're pseudo responsible for them. But at the end of the day, it's the cement companies and the steel companies who need to fix that problem. But the emissions from your fleets, from fuel usage, the trucks moving stuff around, that's often your primary emissions footprint. Would that be the right way to think about it?
For a contractor, yes, because they don't control the design. They get handed a design and say, hey, go build it. So you're right. They really just have control over that supply chain, where those materials are coming from. And the challenge is, at the end of the day, their client wants the lowest cost building. If a contractor says, hey, I can locally source all these materials, but they're all more expensive than the imported stuff, the client's going to say no. So that becomes a bigger challenge as well in the industry.
Can you map out the players in the construction industry, from who are the contractors, who are the developers? What does the landscape generally look like for us?
So typically you've got an owner of a project. They own the real estate. They're a developer, or they're maybe a large tech company that has a lot of real estate in their portfolio, and they have a need for more space. It could be an office building, it could be housing, whatever they would need. So they go out and they bring on design firms to help them scope out what that project is, how many people are going to be in that building. And then at some point they go bring on a contractor to say, okay, we're getting ready to go build this building. Come in and help us build that project. And that prime contractor may bring on hundreds or even thousands of subcontractors and suppliers. Essentially, you set up a small supply chain and a small Fortune 500 company on some of these projects when you get into multi-billion-dollar projects to go supply all this material to a location, and it's all a one-off. So you set up an instant supply chain to do this for a couple of years, and then it breaks down and they go to other projects. So you don't get a lot of repetition to that particular location. So there's just a lot of inefficiencies in doing that. They assemble offices at the job site for all the people that are suddenly commuting to that location. It is a massive undertaking to build a building.
So the prime contractor is essentially the project manager or the product manager maybe of the whole thing. They may or may not directly manage the individual types of specialty teams that are coming in. They're going to find subcontractors who are electricians or who are framers or who are this, that, and the other. They're more of an operationally focused orchestrator, if you will. Is that the right way to think about it?
Absolutely. They're orchestrating a massive theatrical event, we'll call it. And when they're done with it, they leave behind a big building for the client. And they typically aren't the designers of it. They're building a product that was designed by someone else for someone else. So those are your three core players. And then you have this orchestration team, all the people and the equipment that do the work below that contract.
And who's most responsible for cost of labor and who's most responsible for cost of materials?
Good question. It's going to depend on the owner, and the designer can put some requirements in their contracts. For example, some owners say, hey, the project has to be union labor. So then the contractor has to go out and make sure they hire union trade contractors on the project. So sometimes that's dictated for them. Typically, the union agreements are based on regions and trades. So that's typically set. The cost of materials is typically split between the contractor and designer, because the designer says, hey, I want gold-plated toilets, for example. Well, the contractor has to go out and source gold-plated toilets. They may get a couple vendors to pick from that they may compete against each other. But in terms of total cost, it's the designer and the client that are specified.
And does that same responsibility hold true when it comes to thinking about the emissions or sustainability of a building or a project?
Definitely on the embodied carbon. Because if the designer says, I want a concrete building versus a timber building, for example, huge deltas on the embodied carbon. The contractor can't come back and say, well, I'd like to give you a timber building. Here it is. The designer specs concrete. They're going to build concrete. So that embodied side is definitely heavily on the designer and the client to make those decisions up in terms of what their goals are. The good news is we're starting to see a shift. We're starting to see a lot more owners start to measure embodied carbon, operational carbon from the building. Because while embodied carbon is a large amount in it, the operational carbon can far exceed it over that 30 or 40-year lifespan.
So the contractor would be responsible for the operational carbon of building the building or not?
Not really, because again, it comes down to the designers. What are they speccing for levels of insulation?
Oh, operational carbon would be energy usage of the project. Okay.
Then there's, I call it more the logistics carbon or the actual construction carbon, which is where the contractor comes into play. Are they going to bring in a fleet of electric heavy civil equipment, or are they going to run all diesel gensets and diesel equipment for that job site? And when you look at those three categories, what the contractor brings to the table is actually quite small compared to operational for the building and embodied for the building. So that's where it becomes really critical for the designers and the owner to get on board up front And ironically, if there's an existing building, if they can find a way to reuse it, then that's a huge win for them on the carbon side.
And you and I both live in California. There's new legislation such as now state law 253, for example, that's requiring companies to measure and report on all aspects of their emissions, scope 1, 2, and 3. How is that starting to impact the construction industry, if at all?
It just passed. That was January this year. I think it just went into effect. So I haven't seen it because I haven't worked for a contractor for a couple of years. I'm sure like most things, they'll probably be slow to adopt it. I see it as one of those nice tailwinds to help move the whole industry forward and to start measuring it. When I was at the last contractor I worked at, we had a sustainability initiative, which is where I learned about the wood waste problem. And we put together a proposal to actually swap out our pickup trucks. The F-150 gas guzzlers, essentially they're driving billboards for our whole company. And I said, hey, let's go with some Model 3s. You get the carpool stickers, cuts our costs. They pay for themselves in like a year because the number of miles people are putting on these pickups are ridiculous because they'll commute. And it got shot down. And the executive team was like, no, we like our billboards. We like that pickup truck image. And I'm like, okay, this is going to be rough. Even when you show them cost savings and reductions and spending operational money and it's sustainable. Here's a win-win. Let's cut some wasted money and let's do the better. And it got shot down. So it's going to be a tough uphill battle with contractors.
One thing I didn't wholly appreciate, I learned recently, is that most of these fleets, these pickup trucks or whatever that are driving to the site, the people who drive them aren't driving into somewhere, swapping in their personal car and taking the truck onto the site. This is their car or their truck. They drive the truck all the time. It just so happens to be the company fleet truck. They don't own it, but it's their primary vehicle in many cases.
It's the construction perk because you're always moving around to different offices. If you work in the field, one day you could be at a job in San Jose and 2 weeks later you're at a job in Sacramento. So you could have anywhere from a 50 to a 150 mile commute each direction.
And I would assume then things like range anxiety, as you talk about flipping to an EV truck, start to be very real considerations for these contractors as they're thinking about the fleets that their team might drive.
We did the data and the research on it, and that's pretty false. The range these days is 200 to 300 miles. That's fine single direction. Very few people are commuting 200 to 300 miles each direction. That's a long, brutal slog. What we found is most of the people commuting, because what we did is we looked at our employees with pickup trucks. We grabbed their home addresses. We grabbed their job sites they were commuting to. We looked at the distances. We crunched the numbers to look at how feasible is this. And we actually had our superintendents raise their hands and say, hey, we want to do this. We want to use electric vehicles because we could put chargers at home so they can charge at home. We can put chargers at the job site. That's not a problem. So really, they just got to go one direction. So it was totally feasible to do it. It just was a willpower.
That's an interesting business opportunity for anyone in the EV charger space. These fleets often have, as I assume they do, partnerships with local gas stations or whatever to be the place where the fleets would fill up. Maybe it's whatever the local chain of Shell or whatever it is in your area. But maybe there's an EV charger company that could come in and say, hey, we're going to target these fleets and help with home installations.
Absolutely. Home installations. And then a lot of job sites need temp power. And there's companies supplying batteries and solar power to job sites these days. So add on a car charger.
All right. Well, we've uncovered a small, but actually probably sizable opportunity for any entrepreneurs listening, which is think about how you approach construction fleets as a customer segment.
Absolutely. It's a massive number of vehicles out there.
All right. Let's turn our attention to your company, Eric, Urban Machine. What is Urban Machine?
So we are a 2.5-year-old robotics startup that is taking lumber waste from construction, removing all the metal from it, and then turning it back into premium lumber products that you can use to build again with. Lumber is still the predominant building material, especially in the residential space, single family, multifamily compared to steel and concrete. It's incredibly strong. It's beautiful. We can track the story of it. But unfortunately, right now, most of the industry uses it once and then they bury or burn it. So in the US, it's about 37 million tons of dimensional lumber heads to our landfills or incinerators every day. Massive amounts. That's about half of what we log from our softwood forests. So we're on a mission to take that wood and instead of chipping it and then burning it or burying it, take all the metal out because once it's metal free, then we can sell it into the virgin supply chain.
Hey everyone, I'm Yin, a partner at MCJ Collective, here to take a quick minute to tell you about our MCJ membership community, which was born out of a collective thirst for peer-to-peer learning and doing that goes beyond just listening to the podcast. We started in 2019 and have grown to thousands of members globally. Each week, we're inspired by people who join with different backgrounds and points of view. What we all share is a deep curiosity to learn and a bias to action around ways to accelerate solutions to climate change. Some awesome initiatives have come out of the community. A number of founding teams have met, several nonprofits have been established, and a bunch of hiring has been done. Many early-stage investments have been made, as well as ongoing events and programming, like monthly Women in Climate meetups, idea jam sessions for early-stage founders, climate book club, art workshops, and more. Whether you've been in the climate space for a while or just embarking on your journey, having a community to support you is important. If you want to learn more, head over to mcjcollective.com and click on the Members tab at the top. Thanks, and enjoy the rest of the show.
And is that metal contamination, I guess, for lack of a better term, which are nails and screws and stuff like that, is that the biggest reason why wood is not reused today?
It is, because in order to use wood, you typically saw it, plane it, sand it, and all those tools that they use are not designed to cut metal and wood. The most efficient wood planers are very good at planing wood. So when you put a nail in there, it absolutely destroys the blades on a plane.
And yet it can go through a chipper with the nails still in it?
Keep in mind, it's $1 million to $2 million chipper with a massive diesel engine and massive teeth, and it requires a lot of maintenance replacing those blades. But yeah.
Okay. And is there any change in order to reclaim the majority of wood from I assume a demolition site is what we're really talking about here, more so than a construction site? Is there anything that needs to change in how buildings are demoed?
So for demolition, we're huge fans of deconstruction, because what that does is it increases the quantity and quality of material we can recover. Typically, if you smash it up with an excavator, you end up with a bunch of small chewed up chunks. That's pretty hard to reclaim. If you cut all the fasteners and take it apart in studs, then you dramatically increase the volume of material. And surprisingly, construction uses a lot of lumber just in temporary structures. Think about safety railings, holding up walls, formwork. There's a lot of material that comes off of job sites just in building buildings.
The scaffolding and all that you have to build.
Exactly. So lumber is not just in the walls, but it's all over the place on job sites.
And on the demo side of things, roughly, what's the best practice today? Is it deconstruction or is it just smashing stuff up with an excavator?
So best practice is deconstruction. Unfortunately, the majority are still smashing. We're actually seeing a unique tailwind where, because municipalities are responsible for waste disposal, they're driving the deconstruction ordinances. So what they're doing is they're requiring source separation and deconstruction and all these ways to keep wood out of the landfill, because nobody wants to go build a new landfill. If you thought building a new building is long and arduous and expensive, can you imagine building a brand new landfill? It's about a 20+ year journey and a lot of money. So most of the government agencies want to keep wood out because it's one of the largest contributors to landfill space by volume.
So there's regulatory tailwinds. I'm guessing most contractors don't necessarily love being forced to do something, but that's where you come in, which is you say, hey, these regulations are happening and we can help you solve your problem around this. Would that be the right way to think about it?
Absolutely. That, and then it's very expensive to get rid of material these days. To truck it off the job site, take it to a waste facility, they charge a tipping fee, $50 to $200 a ton. There's quite a broad range on what you're paying for it. It adds up. It becomes a lot of money very quickly.
How did you discover this particular need and decide this was the problem you wanted to focus on?
So when I was at the last contractor, I've done startups before. I work with startups, bring them into job sites, startups where you can actually move the needle if you want to solve a problem. It's very hard to do it at large organizations. So while I was there, when we were doing our sustainability research and you come across a massive problem, you're like, ooh, this is interesting. Massive problem. What's going on here? And you start doing a little more research and you find out it's the metal fasteners. So I reached out to some robotics folks I knew and I'd done some research with before on other projects and said, hey, could we automate this? Because the problem with metal fasteners is just too laborious for humans to do at scale. It's never going to happen. So it's a perfect problem for automation. So Andrew, my co-founder now, said absolutely. And within about 30, 45 days, he built a benchtop prototype. He had a web camera and a pneumatic nail shooter kicking nails out of 2x4s. And it's like, ooh, this is promising. And then reached out to some investors and they're like, yeah, we'll write you checks for this. And we're like, oh, okay, we're off. Doing this again. My wife's like, oh man, not again.
Maybe describe in a bit more detail how the system works. You have, I think, 3 main technology components to your system, if I understand it correctly.
So over the last 2.5 years, our tech has evolved. We're on version 5 that's out in field trials right now. And version 6 we'll start testing here end of April. So there's 3 core processes to it. The first one is what we call cutting. And that is where we cut all the metal fasteners to essentially normalize the dimensions of the wood. If you think about wood and it's got nails and screws sticking out, 2 to 3 inches going all directions, we call it the porcupine state. It's very hard to handle in that state. So what we've done is we've developed a way to cut all those fasteners down. So they're just little tiny nubs sticking off the wood. And then what we do is the next step is we want to reduce the friction it's going to take to pull those fasteners. So we cook all the fasteners. We use induction cooking. We heat up the fasteners, and the real win is on the screws, because what it does is it breaks down the fiber and the threads. So instead of requiring hundreds and hundreds of pounds of pull force to get that screw out, we can do it with 10 to 20. And then what that does is it feeds the third step, which is literally plucking all these fasteners out of the wood. So we have what we affectionately call our birds, which are bird beaks on top of electromechanical cylinders and actuators that go in and pluck all those. And we use computer vision throughout the whole process to identify the fasteners, to orientate the cooker, orientate the picker, and get all those fasteners essentially cut, cooked, and then removed from the wood. And then we run it through a metal detector to make sure we got it all.
This is a much stronger version of me with my needle nose pliers, essentially, would be the bird beak.
Exactly. You got it.
Who is your target customer? Who are you targeting with the product?
So we're selling it back into construction. So we're selling it to wood manufacturers. We're selling it to lumber yards. We're selling it back to contractors to use for handrail and temp structures and other general use products on their projects. Essentially, we're testing out lumber rental. We deliver it to a project. They use it for the duration of the project. And then we take it back at the end of the project. We clean it all up and we sell it to another contractor or rent it to another contractor for their project. It's really a cool model that we're playing around with.
And you've described, obviously, what the machine is and what it does. You know what you're selling. You're selling, here's wood, here's the ability to reuse the wood on your site. Do you have a sense from their end of what they think they're buying? What is motivating them as a buyer of this solution?
So the contractors that are buying material from us, they're doing it for the sustainability because their architects and their clients are asking them for it. Saying, hey guys, we need to reduce the carbon footprint of our projects. Come to us with solutions or ideas for ways to do that. So this is one of those ways. Lumber is a great storage tool for carbon, and we believe it should be stored in building walls or in use instead of in a landfill or burned up and released. So this does that. The other thing that's great about wood that you can't do with concrete and steel is we can actually tell the story of its past. So we can take wood from an old building. We can track it through our process. We can tag it with a QR code. And then the new owner of that building or that wood can say, hey, look, I'm using reclaimed material. In reclaimed lumber, the EPA did some great studies for us where they found it takes over 90% less energy to reclaim lumber than it does to harvest virgin. Virgin lumber is awesome. It's a nice natural product, but it takes a lot of carbon to cut down trees, process trees, dry the wood, ship it. There's a lot of energy involved with that. So using something that already exists, that's already close to the customer, is a massive win on that logistics carbon.
So I would assume that the eventual user of this reclaimed lumber is able to be very vocal about it. We built our building with all reclaimed lumber. It's more sustainable. Here's the emissions impacts, et cetera. But for the project sites that you're coming to the sites that may or may not be using the reclaimed lumber. They are contributing lumber to go be reclaimed. How did they think about that benefit? That isn't a category I've heard yet a lot of people talking about. We may still be building the thing on this site using virgin wood and whatnot, but hey, all the lumber that we tore down to build the new thing, we've contributed it back to reuse in the future. That's a harder message to communicate. How is that starting to play out?
It is, but it's a good entry point. It's a pretty easy entry point for the project teams that we're working with. They're like, oh, instead of us paying somebody to haul it and chip it and burn it, we can give it to you guys. So we're saving money and we get a more sustainable story. Oh, that's got us interested.
Got it. So the money savings seems like a big part of it. You come in, you show up, and are they paying you to do this? Or your payment is the fact that you get all this wood to go sell to somebody?
Some people are paying us for it, depending on the wood that we're collecting from them and what's required on the logistics side. But most of them are just giving it to us. So our raw material is no cost, which is a great starting point when you're in the materials business. And then we just have to clean it up and then sell it back into the market.
So you have to ultimately become the best and most efficient source of reclaimed lumber to the construction industry. And as a result of that, the project sites that are inviting you onto the site start to do so because they can save money not having to pay someone else to take this wood and go landfill it or chip it. And that allows you to build this reclaimed lumber business. And your business is built mostly selling the wood after you've treated it.
Today, yes, we are in the lumber business today. Eventually, we want to pivot out of lumber and be in the robotic space where we're just selling the machines to operators, essentially the franchise model where the machines and the process are going all around the country. We view that as the fastest way to scale it. But today, here in Northern California, we are in the reclaimed lumber business.
And your machines are on site, on the construction site, or is the lumber getting shipped to you to be treated?
Right now, it's getting shipped to us. We could deploy at really large sites if they're taking down, say, 100,000 square foot old wood building. But today, most of the contractors ship it to us because our machine is too big to set up.
And is that how you envision it ongoing? You'll have hubs in key cities around the country?
Every metropolitan area that has waste wood will have a system operating there, processing it as our goal.
So it seems like there could be optimizations to help with that fleet emissions problem we talked about, but that may not be in the cards for you all, just given the complexity of your setup.
Well, here's a really good one that we're pulling off. So because we're partnered with a lumber yard, they send the truck out with a delivery to the customer, and then they pick up our waste material on the way back. So we're cutting the number of trucks in half. We're using empty trucks to bring our material back to our yard where we operate, which is a huge win. If you can cut the number of truck trips going to a construction site in half, not only is that a win on the carbon footprint and the air emissions, but it's also a huge win on the traffic and the impact to the neighborhood and those in the building area.
What's your deployment footprint look like today, and what are you hopeful for over the next 1 to 2 years?
So robotics is always much harder and longer than software. My last company was SaaS. Within 6 months, we had a minimum viable product. We had people testing it, clicking on it, using it. We will be delivering our first machine to our client up in the Seattle area in fourth quarter of this year. That'll be our first paid customer deployment. And then our goal is to get 11 more out next year. So that'll be to 11 more metropolitan areas here in North America. And then we've actually already got our first LOI signed from a client in Europe that wants a machine in 2026. So we're actually getting inbound interest from Europeans, Australians, New Zealand, everybody who's got lumber buildings for delivery starting in 2026.
What are your big unknowns right now? What are the things you need to crack in your company at the moment?
So I've got to close a Series A. So we got to pick up another bucket of money. Really for us, the tech risk is just about done. We're finishing that up here in the next 2 months. And then we get to start to move into, okay, we've spent 2.5 years doing R&D. Now we got to go deliver these to customers. We have to train customers. We have to have manuals. We have to productize it. We got to make sure the machine operates safely and hits all its metrics. So that's going to be a big shift for the company. How do you take the research hat off, put on that deployment production hat? And then the next one is how do we scale this? So we go get a dozen customers, but how do we go build thousands of these systems? Because it'll take somewhere between 12 and 18,000 systems to saturate the market around the globe.
For these first dozen, it sounds like you're planning to operate and staff them. But as you said, the future vision is that the contractors actually run these systems.
Not necessarily the construction contractors, but we'll have waste facility partners and people that process waste wood, deconstruction, demolition contractors. Actually, these first 12 are going to be operated by our partners. So only the one that we have right now is operated by us. The one in Seattle will be operated probably a demolition deconstruction contractor up there. So what we've done is we found a lot of folks want to run these machines. It just takes general labor skills. So there's nothing real specialized to operate them. And there's a lot of people that are like, we need this in our area. We have a wood problem. We have too much wood. We're tired of burning it and burying it. Our landfills are filling up. You guys have a solution. So we have people reaching out to us and coming to tour our facilities and see the machine and plan building facilities. By the end of Q3, we should have all 12 systems reserved for next year, which is awesome to have a backlog of customers ready to go.
And you mentioned at some point a Series A on the horizon for you. You last raised a seed round in 2022, led by Lower Carbon Capital with participation from GV or Google Ventures. What more do you want to share about the history of the company from a capital perspective?
So we started with a pre-seed back in November of 21. So that was led by Union Labs and Catapult, who have been awesome investors. They invested in the people. It was me, Andrew, and Alex. It was 3 guys with this crazy idea and a benchtop prototype. And they wrote the checks for us there. We spent about a year proving the tech out that said, yeah, the computer vision and the electromechanical assemblies can automatically remove nails. And then Lower Carbon and GV joined in 22. And we've been focused very heavily on proving the economics. Because the construction industry, while a lot of them want to do better, nobody goes out and says we want to destroy the environment. But it's all about the economics. So we've been very clear that we have to compete with virgin lumber mill prices. We got to bring down the price of reclaimed lumber for it to scale. So the last year and a half has been purely on driving the economic productivity of our machine and our labor force and making sure that we can move material competing with virgin lumber. So as we hit that milestone here with this next iteration, that's why we're kicking off the Series A raise.
Eric, what more should I have asked? What more should we have covered?
So we covered the technology, we covered the machine, the market, the labor, the lumber. Most people ask why I do this.
Eric, why do you do this?
Why do I do this? It's fun. As crazy as it sounds, the ups and downs of startup life. I've worked for large companies, worked for small companies. And if you want to change something, there's nothing like a startup doing it. And this one's awesome because nobody has said this is a bad idea this time. Whenever you start something new, there's always naysayers. We've had zero of those. Everybody from contractors to trades to the conferences we go to, they're like, this is awesome. It's badly needed. So really the ball is in our court to solve the technology problem and get it to market, which is a nice place to be in. To have people reaching out to you from all over the world and saying, hey, how do we get one of these systems for our metropolitan area? It's a good place to be.
Well, I appreciate you joining us today and sharing more about what you're building at Urban Machine, and also just helping all of us understand more about the broader construction industry in general. And certainly wish you all the best as you continue to build this. And reclaimed lumber is beautiful. So I think the more of it we can get into construction, get into buildings, obviously, the better overall, not just from an aesthetics perspective, but from a sustainability perspective.
Awesome. Thank you very much, Cody. It was a pleasure to be on your show. Great conversation.
Thanks again for joining us on the My Climate Journey podcast.
At MCJ Collective, we're all about powering collective innovation for climate solutions by breaking down silos and unleashing problem-solving capacity.
If you'd like to learn more about MCJ Collective, visit us at mcjcollective.com. And if you have a guest suggestion, let us know that via Twitter at MCJPod.
For weekly climate op-eds, jobs, community events, and investment announcements from our MCJ venture funds, be sure to subscribe to our newsletter on our website.
Thanks, and see you next episode.